Hello everybody, my name is Quinn Fischer and I'll be teaching you about partial fractions. So, let's go ahead and get started, shall we? Today we have a relatively easy one, and we're going to start out by 6 easy steps. First one being to separate the bottom, which just means we're factoring it out, making it so we can more easily see what the different parts are. So, x plus 1 over x to the third plus x dx is the same as x times x squared plus 1. As you can see, dx. Now that we've got that done, we're going to set up our a, b's, and c's. So first we have a linear portion, which will be represented by the equation a over whatever linear portion you have. So in this case, it's going to be x. The quadratic portion is going to be represented and added to the original by bx plus c over your quadratic portion, which in this case is just x squared plus 1. So we're going to go ahead and we're going to take that equation and we're going to set it to equal to our original equation so that we get an equivalent version of our original equation. So, multiply those over, you get a x squared plus 1, or a times x squared plus 1, or ax squared plus a, plus bx plus c multiplied by x, which is going to give us bx squared plus cx equals x plus 1, since we've gotten rid of that denominator completely. So, now that we've made that, we're going to go ahead and set up our system of equations. Our linear equation is going to be all the linear portions, or cx and x, which just means cx equals x, c equals 1. Our quadratic portion is going to be ax and x, which just means cx equals x, c equals 1. Our quadratic portion is going to be ax squared plus bx squared equals 0, since there's no quadratics on the other side, which means a plus b equals 0, b equals negative a. And our constant equation is going to look a little bit like this. All the constant parts set equal to each other on their respective sides of the equal sign. So a equals 1, therefore b equals negative 1. Now we're going to plug that into our original equation. We wind up with the integral of 1 over x plus bx, or negative x, plus 1 over x squared plus 1 dx. And we're going to go ahead and not only break this up into negative x over x squared plus 1, but also 1 over x squared plus 1, and then we're going to distribute. So we're going to go ahead and distribute and then break that up. So we wind up with 1 over x dx plus negative x over x squared plus 1 dx plus 1 over x squared plus 1. Next, we're going to go ahead and integrate. We know that this is ln of x. We know that this one is arctangent x. But what about this one in the middle? That one looks a little rude. Well, we're just going to use some u substitution. So, u equals x squared plus 1 du equals 2x, and since we only have one x and it's negative, we're going to go ahead and multiply that by negative 1/2 to get what we need. So we're going to get the integral of du over u times negative 1/2, which is just ln u times negative 1/2. So minus 1/2 ln u. Now what are we forgetting? To plug u back in. X squared plus 1. And what are we going to add to the end? What do we always add to the end? Plus c. And that is how you solve a partial fraction. Thanks for joining me.